Уважаемые участники, теперь мы переходим к повестке нашего академического коллоквиума. Dear guests, we are moving forward to the agenda of our academic colloquium. И слово предоставляется Чжун Лин Ван, and the floor is given to the Чжун Лин Ван, founding director, Beijing Institute of Nano Energy and Nanosystem. The topic of the presentation will be triboelectric nanogenerator, a revolutionary technology for future energy and sensorics.
First, I'd like to thank Global Energy Prize giving me this great honor, and also a privilege for me to visit Moscow Energy Institute. And it's a great honor for me to give a presentation here, especially on non-conventional energy, something you probably never heard about that, and I want to present you a new approach that have a potential to change the way we generate electricity in the future. Okay, so my title is Triboelectric Nanogen, TNG, a revolution technology for future energy and sensing. Okay. Does this work? Okay. So as we move into the next generation energy, we need to do something innovative, especially on the energy we have. And the energy we have is coal, oil, and gas, those fossil energy. But we overuse those energy, we face challenges. For example, let me see if this can work. The remote control have a long distance. Okay, let me see. So today we rely on the fossil energy. How long is it going to last? There's data shows that. Let me see, okay. We use coal, oil, and gas. And the data shows that by end of this century, we're going to be last end of this fossil energy. Today, 80% of power rely on fossil energy. But we're going to finish up by end of this year, this century. So therefore, where are the new energy going to be? This is a huge challenge for sustainability of the entire humankind. So that's what we want to see. Where the energy go? How can we reutilize such energy? So if you see such energy, once we utilize that, they are distributing our environment. We cannot reuse them again. So how do we harvest those energy to make humankind sustainable? Is a new challenge. So we work a lot on this thing, on the fundamental ones, as well as technology impact. 2006, we made a discovery, so-called a nanogenerator, use piezoelectric effect for harvesting energy, and we use such effect demonstrate we can be able to do that in principle. However, the performance and the efficiency is rather low. So in the last 12 years, we developed a lot of time and develop new technology, use triboelectricity. Everybody knows triboelectricity, but how can you generate electricity effectively is a big challenge. So therefore, we discovered this in 2012, as now it's become a new way for energy conversion. So I want to present you the fundamental physics, science impact, as well as technology impact, okay? And then you say, what's the difference compared to what we have? What we have now is use electromagnetic generator, which was first invented by Faraday 1831. And it works good for higher frequency of mechanical tricking. That means use steam engine, you can do that. But for the energy distributed in our living environment, it is the efficiency so low because the output power is proportional to the square of the frequency. Our TNG on the right-hand side is a new way to do it because it gives the way to take unconventional energy low frequency energy, low amplitude energy into effective electric power. So we first invented 2012, okay? Now, as this was invented, they said, what's the big difference compared to what we know? The first one is frequency dependence. And it's very good for low frequency tricking. Have a low frequency tricking, it'll give you a high output power compared to traditional technology. That's a big difference. The fundamental principle is different. So use a triboelectric effect, electrostatic induction, two effects rather than electromagnetic induction. So the physical principle is different, and the performance, of course, is different. So the frequency is different, the dependence difference. As low frequency, the performance is 10 times of electromagnetic generator. And the other one is amplitude. If you have a lower amplitude, once the energy distribution in our environment is in low pace, how do you affect such energy to electricity? We found for low amplitude, the performance is 5 to 10 times better than traditional technology. So this is the performance we demonstrate. The other one is the energy conversion efficiency. As you see, once you have a lower power input density, the conversion efficiency is 3 times better than electromagnetic generator. Even today, we use the most power magnets. Our performance here is high. So this is something you probably never heard of. Our new way convert energy into useful power. Okay, and this is the basic principle to compare. They say what material you can utilize. A lot of cases say, oh, we use magnet coils, but this one no. They use organic materials. The materials we are used in everyday life, fabric, a lot of things. So this material choice is broad, and from organic to polymers. We use triboelectric effect. So this is the material choice, broad. Then so worldwide, since we discovered nanogenerator from 2006, now is 16,000 scientists from 83 countries and regions who are working on this technology and related. Over 15,000 papers have been published in this field since our first paper for that. So it's a new way to utilize energy, different from wind, different from solar. Those you call new energy, it's just new compared to the fossil energy we use, okay? So this is the impact, worldwide impact. What's the application? First one is small powers. The second one is sensing technology. As we move into the smart city, smart society, intelligent, artificial intelligence, we need the sensors. This is a very good way to do that. I want to give you a fundamental impact of our science, okay? So they say, this invention, what are the basic things to impact our science? Let me show you the impact. Well, triboelectricity, everybody knows that. This has been centuries. But what's the physics behind? How is the electron transfer, ion transfer, or material species have been debated for centuries? Okay, until very recently, we found this is mostly electron transfer because we find that when you do two things together, put one together, the triboelectricity occurs. Then say, why the two things have been so close? That means that the atom has been so close, the electron can transfer from one to the other one. We do the spectroscopy analysis, find that's the case. So for the first time, we unified the mechanism of triboelectricity is mostly electron transfer. That's the way to do it. Electron transfer has to be social with many things in our material system, from molecular level to atomic level and even to structure level as well. So this is the first things we establish, the fundamentals one. The second one is, do you have, when these two things together, if you have electron transfer, do you have a photon emissions? We measure that, we find it truly have photon emissions. So cross the atom into atomic, electron transfer and transition result in photon emission. We do verify the model we propose. So if you say something new, scientific has to be new. Okay, so no, otherwise the technology just incremental advances. Okay, so the second thing is, how about liquid and solid? You know, we have a lot of cases. The triboelectricity occurs not only between solid and solid, but also on liquid and solid. Okay, so I want to show liquid as well. It's happening in our daily life. Okay, so this is a very fundamental thing in chemistry, so-called electric double layer. This is something all the chemistry students study, chemical engineering students study for that, but we subject to revision because not only ion absorption for the electric double layer, but also have electron transfer. So we did this experiment. We put a droplet of water on the silicon dioxide. We found that they have electron transfer. We can measure the charge decay mechanism as a result of applied temperature. And we did verify both have electron and ion transfer. That's why for electrochemical storage, a lot of systems are unstable because electron transfer at the interface for that, which is something we did not believe it was before. So this is the ion transfer for that. And we also transfer different materials. How about different material? Does this principle apply to all the materials or just a few select one? We found it is a universal model for that. Okay, so this is what we found, not only for silicon dioxide, magnesium oxide, silicon nitride, titanium oxide, all this kind is very universal. Then say, well, if water transfers electron to solid, is this true? Used to believe no. We say water cannot become ions, but now it can. Water become ions, lose one electron, become water ion. But the lifetime of water ion is only 200 peak second. So a few years ago, the experiment found this is the case. So water can lose electrons and become ions, but this ion do what? Combine with the other species in water, become radicals. So this is what we found just from a physics point of view, chemistry point of view. So, and this do support one. So therefore, we revised the formation mechanism electron double layer at a liquid to solid interface, because as you have electron transfer, some of the dynamics at the interface will change because you have both electron transfer and ion transfer coexist. So this is the first thing I want to show you, the fundamental impact due to the TNG invention. The second one is what you can do. This can provide new way to measure the charge transfer between liquid and a solid quantitatively. To map, when you have dropped water flow down, you can map the charge distribution across the map as a probe for fundamental chemistry study. They say, well, did we know about this before? So when you do chemical reaction, you always steal the chemical reaction, but you don't know that there was an electron transfer. We measure this one due to charge transfer, you can light up light. So something we used to do every day, but we didn't realize there's electron transfer involved until we found a reason for that. So I just give you a little basic of the science we found for that. Okay, so this is the scientifically innovation. Okay, the second one is that can you do catalysis, use counter-electrification? Because in nature, how does the catalysis occur? Is counter-electrification. We don't have the expensive man-made catalysis, but this has happened. We found it for this methanol orange degradations. If you have this FEP beads, put that, you apply a sonic wave, it degrades. That's the happen in our nature to the chemical degrades for that. So what happens if you have FEP beads? Contact with water, water lose one electron, become water ion. The water ion will combine with water molecule again, form two radicals. And then the FEP on a sonic wave release the electron, and electron combine with oxygen, form two new radicals. That's the cycle of our nature happens. So you have floating water never get deteriorated because you have the floating, the electron transfer between water and organic substrate, like such as stones, right? So this is the way from a new principle for that. So also we find a new effect, the trouble voltaic effect. You know, we know the photovoltaic effect. Photons shining get DC out, but this trouble voltaic also can happen. So if you have a N-type semiconductor slide on top P semiconductor, you have a DC current come out. This is something we didn't know before. And we just 3 years ago found, yeah, if you start with P on the end, you can have DC current out. And this is a new effect called trouble voltaic effect. And it can be for sensing and also for semiconductor data reading. So this from our study, we found this is the case for that. Okay, so this is chemistry. How about physics? How do you impact physics? This comes to the theory of electricity and magnetism. Okay, we want to quantify that. If you have a conductor that cut electromagnetic flux, you can generate power. All right, we know that for decades. Now, there's two kind of current. One is flow through the wires. That's called conduction current. The other one is called displacement current, which is transmitted from space, which is Maxwell invented that in 1861. But those equations derived on the assumption. They assume all the medium are at a station. That means all the things are stationary, nothing move. So all the electromagnetic theory derive on that assumption, but this assumption rarely mentioned in textbook. Just say all the general students accept as it was, okay? So now we say the media is moving. You have to revise the displacement current, which was first unified in the 1900, 120 years ago. And because we have the media moving, you have to introduce, beside this displacement vector, you have another term due to motion. If you have a relative motion between one and another one, you have to add another term, use which we'll be able to quantify the output power of a TNG. So I, from an experimental side, to propose new theory, be able to add in an equation for that. So this just show you the fundamental impact, use which we can quantify the data output, use the TNG output to compare theory, and progress very well. However, as you advance, new experiment shows new challenges. And the challenge is this, is that media motion can give you electromagnetic radiation. Okay, let me give you one example. If you have a windmill around you, this thing rotates and affect animal behavior, human behavior nearby. Why? You have a low frequency electromagnetic radiation. So this is the motion generated, but this was not included in the original equation for that. They did not consider this one in Maxwell's time. But now you have to, because we measured this experimentally to do that. I want to show you this subject for students. You can learn from classical physics, but at the same time, it's subject to expansion. So this is we found experimentally, we can transmission power use medium motion. And another one is that we measure this underwater. If you have a voice sounds to TNG, it generates displacement current and can transmit signal underwater a few meters away. And this was used motion of medium, use electromagnetic wave radiation. Okay, this is something we didn't know very much before, and we measured this experimentally, which make us to rethink about the theory. Can we expand for that? Okay, so. And this is the experiment, we observed that due to medium motion for that. However, if you look at textbook, they say, well, all these things come from the flux rule. Flux was presented by a Russian scientist, Lenz, many years ago. That's the power. All the power generated based on that principle. But they found to have the anti-flux rule. Some case, you don't have anti-flux because the medium is motion. But such motion was not included in the equation because the equation assumed everything at the stationary, fixed it. But this medium is moving because as a result of this Maxwell equation, we have to add the second term, V cross B term. That's due to the medium motion. We have to add it in. All right? So this is the basic, due to the medium motion of the disk. One said, why would this was not included that one? Well, previously, we have the equation with derivative say assume everything is stationary, so the derivative of that applied to medium vanishes. So you didn't have this term. However, now we have the medium motion, we add that term, okay? Because this is a mathematical, I will just simply skip that one. The reason is what? If you have a disk rotating, the geometrical path is different from the trajectory of the electron move in a disk. That's the difference, make a so-called anti-flux rule. But which not well explained in textbook. Just say, okay, forget about this, you keep going. So general students didn't consider this one until I noticed a few years ago. So if I have medium motion, but that term was not included in Maxwell equation. So we have to expand that. So I derive from mathematical for that one, finally put an equation, we'll be able to do that. So if you look at the right-hand side, is you have a disk rotation, right? If a disk rotation, due to disk rotation, you have the additional term Maxwell equation. That's inside the disk. But outside the vacuum, still the standard Maxwell equation. The solution of both meet at the boundary, set for boundary conditions. So therefore, this medium motion give you low frequency electromagnetic radiation. That's why you have a wind turbine machine around you. You have this radiation which affect animal behavior, even human behavior. So if you overdevelop this one, you're going to end up with some issues, especially health issues for that, okay? So we include that one, in the equation. The reason I tell you this one, it seems not much with the energy, is we start a new energy, we find new science. The way make us look at classical physics, classical chemistry from a new angle, and then we can develop new things. Okay, so this is my first half of my talk to show you when you look at new energy technology, there's new science there, something we didn't realize before. So this, I want to show that. They say, what's your contribution? If you look at the left-hand side, is Faraday's contribution for power generation. And this is what we use for today's power. On the right-hand side is for use for communication. On the left-hand side, assume the rotor is rotating, give you power generation. On the right-hand side, say everything stay stationary, give you electromagnetic radiation due to oscillation of current. But there's an inconsistency between the two assumptions. When you near the two things together, one is moving, one is not. The theory have a gray area which we did not cover. So use the equation we derived, we'll be able to cover the gray areas due to the medium motion, and that cover that. Okay. So this tell us when we teach students, say, be challenging, be innovative, be creative. So you'll be able to do something other people never thought of before. Because hundreds of years ago, who considered things moving? Okay, there's no aircraft, nothing, no cars that time. In Faraday's time, in Maxwell's time, they didn't consider about that. Today we do. And we can have things fly at high speed, sonic wave, multiple time of sonic speed. Then things changes. So new technology, new application, bring new things. So therefore, if you're engineering, you have to consider this from the approach two we develop. If you do in the vacuum for universe, use the special relativity. Two things work on different system, and they are one complement to the other one. In the special relativity, they consider point charge moving in space. You can see that stars, universe, that's one. But on Earth, everything have a shape, have a size. If that moves, you need to reconsider that for our case. That because our sustainable development of our humankind rely on all the resources we have on Earth. So we have to consider that. So the two approach, I developed approach two to make sure we be able to cover that in our engineering systems. Okay, then you say, well, what's the use of this one? When the Faraday invented the phenomenon, 3 years later, learned to put this in principle. And 24 years later, Maxwell wrote down the equations. But until he died, he didn't see the electromagnetic wave. Until 1888, 9 years after he died, scientists Hertz found, yeah, there was electromagnetic radiation. Otherwise, we would not have this today. So something we did not see immediate application today, but you never know in the future. So be open mind. So we have the open mind. Same time, we have consistently work on that. I'm going to find application as well. So this is our spirit, our strategy on the science. Okay, I talk too much, but I say, well, why do you get the prize on a non-conventional energy? Do we get this one because of this question? No. Let me show you the impact of our technology to truly industry. And last, I'll talk about how do we harvest energy from ocean wave. Low pace, low frequency energy uses this technology. Let me go one step by step. Okay, so we'll do the 5 areas of application: medical, health, environmental, solar power, security system, micro energy, and blue energy, and solar power sensors, as well as third generation semiconductor. So this is the 5 industry things we try to develop. Let me go just some examples. First one, pacemaker. 14 years ago, I started with students, can we make a pacemaker self-powered without a replaced battery? After 11 years work, we did it. For the first time in the world, use our TNG, we can make it a pacemaker self-powered continuously. So this is impact to implantable medical device, implantable devices, a new way for healthcare, right? So this is the first thing I show you, self-powered pacemaker. The second one is infrastructure. You can have water meters and everything, water, oil, and gas. But you have to send somebody to read it, to give you the numbers. Okay? Now what's the flow rate? What's the flow speed? What's the pH? What's the chemistry of the water? Can you do the analysis remotely, especially on the ground? Especially today, a lot of the infrastructure on the ground. You cannot send a human to do that. solar-powered chemistry flow measurement system of water. We made this possible right now. We are already set a company to commercialize this infrastructure monitoring system. So you can, a whole country, like you know, Russia have a big country, huge country. How can you monitor many things across at a long distance? Become a challenge. So this will make use this TNG-driven solar power system. The second one is the air filter. You know, a few years ago, this is about 7 years ago, China has a pollution problem. Now it's much better. And then how can you do this pollution removal air filtering? So we invented this company 7 years ago. Now we're already using subways, office spaces, use trouble electric filter, air filter, already commercialized on sale. So we started this company 7 years ago. Now we're already in business. Okay, so this is the trouble electric air filtering. Utilize the principle. The other one is the medication. Okay, there's especially for Chinese medicine, they have to diagnosis through the pulse, but measure the pulse become a challenge. They can only do the skilled person, have many years experience, that can tell you something with your health problem, but unable to transfer from one person to the other one. Can we digitize this? Can we make these things transfer? The younger generation can learn from the old generation without go through many years experience. So we use this technology, develop medical devices to quantify this and digitize that. So this is, and the other one is the patch. So sometimes when we do sports, we feel the muscle pain, and we put a little patch on top of that, so pain relief. So we use TNG to be able to stimulate the penetration of the drug into the skins much more effective, 5 times faster. Okay. We also have the professor. They did this beauty. The supplies. This can make for get rid of wrinkles and make the skin younger and healthier. Use this field stimulated medical device. Same principle, but it depends where you apply for that. So you can see every corner. It's only just no power. Sensors, medical care, environmental monitoring. And this is security. If we put it on the floor, somebody walk over, signals automatically record without power. You don't need power. When you step on that, as a radiation goes on, and you get a trajectory automatically recorded. So this is the security system. All right, and then you have healthcare. You know, some people have the leg problem. You go to hospital. How do we know recovery? So we make these sensors at the joints. So if the recovery, they can tell you how many cycles, the force you apply to recovery. This all need for robotics. For robotics, as well as healthcare, they need the sensors. If you use this electromagnetic generator, it's very heavy, bulky, and power consumption. But use plastic, it's very light and useful. This is the principle we invent, TNG, in this process. Okay, this is for healthcare. Then, let me see. Oops. Okay. For let me see. We could put in the shoes. And when you're walking, the shoes can be able to GPS position, because the power put in the shoe insole here, you're walking and they get an automatic location tracking for that. For elder person care as a children to take care as well. This is small power, but it's useful for some purpose for that. Okay, GPS position, cell power shoes for that. Even for aircraft, turbulence happens in the aircraft. But the monitor turbulence is always on simulation. You cannot do that accurately. So use our TNG, we put on the surface of the aircraft wing. So this is a simulation. You can see when the aircraft wing, the angle change, you can turbulence occurs, but it's very not good for safety of flight. Okay, so this is the way how they do it. All right, they do the string on the wing, and they just watch how the string flinks. They can tell you the turbulence, but it's non-digital way. So we put this one in a digital way. Is the TNG put on that. So when the wind go through that, the things have a normal pressure, flow speed, as well. All the things can be detected for that. So it can transfer for aircraft industry as well as other machines for that. So this is the way we invent for the first time for that purpose, for aerospace engineering. You can see, not only for power, for sensing. Okay, so this is the turbulence monitoring on flights. Anything you can think about. Environmental monitoring. We can make this little wind generator here. We put the carbon monoxide sensors So you can write a box over there that can tell you, immediately send to the cloud, the concentration of carbon monoxide. Especially today, you're carbon neutralized. Do you know how much carbon you emitted? You can only say from GDP. GDP is not a measure of carbon emission, okay? But you can locally distribute that. You can measure this one. You can see which area have more carbon emissions than other areas. So powered system for environmental monitoring for gas, chemical, fire, anything. Especially you have a vast environment. Who's going to go there to look at how much there's any fire, anything happened there? Use distributed cell power sensors. You don't need to maintain that in any kind of short period of time. They just send signal automatically to the cloud. You got it at the same time, all right? So this is you can see for that. Now, how can our invention make a human society sustainable? Can we make something to the future energy? Okay, let me show you the potential. There's a report between Chinese Academy of Science and the European Academy of Science that say the possibility to substitute fossil energy is use ocean energy. Okay? This is the future. We use up all what we have on land. Where are the ones? The ones in the ocean. Okay? But ocean is very complicated. It's vast, low frequency, random, but the depths and complicated environment, but that's what we're going to have for the future. So when we're going to need this one, I think need it right now, because we're going to run out of fossil energy by the end of this century. How many years left? 70, 80 years left. It's very short. So if we don't develop something right now, innovatively, creatively, we're going to run out of problem by that time. So this is the blue energy dream we want, okay? But we know we want it, but how? A lot of things is, how do you do it? You know, the politicians tell we need it, but how to do it? Ocean have a 76 terawatt, is 4 times world power consumption today. But how do they do it? Well, use the electromagnetic generator. This is a complicated environment, a corrosion problem, and as well low efficiency, especially low frequency, unable to do it. Okay, how do they do it? They use this propeller for the wave, but not everywhere have wave. Only have the shore have this wave, but the efficiency is very low. They come and go, and come and go, slow pace, slow, right? Unable to meet our large energy need in the future. This will not work. Just only at a special location can do this. So how to do it? 2014, I wrote an article saying, I have an idea. What is the idea? We make a ball inside a shell. If you put this ball in the water, this ball is moving back and forth, regardless which way the citation is. And then, if you make a networking of this ball, we'll be able to generate power. We call blue energy. Then you wonder, how much power generate? Let me give you numbers. This is all measured numbers. It's not just similar numbers. So this is the idea, 2014. I proposed this in a paper. Well, so why you can do it, traditional technology cannot? Because traditional technology, the output of voltage and the current, both are linear dependent on frequency. If a low frequency, the thing is so low, you cannot do anything. So that's why our power, you have to raise the dam height as the propeller that give you the power. If you have a low pace, the creek, you're unable to do it. Okay, so it's a principal limitation. Now, if we use the TNG, the output voltage is independent frequency, only current dependent frequency. If you put together our power is linear to frequency, use organic materials, you'll be floating on the water. You can see that video. We put 16 balls together. Each ball gives about 300 volts. But the current all can add up. So if you have many of these balls, you have a sustainable, constant DC output. This is something you cannot do with the electromagnetic generator class technology. So this is an innovative, new way for future energy generation for that. Of course, this is just the beginning. Let's say, in order to do that, we have to improve it. Not we can improve the density. We can have many things impact in a short period, short volume. You can see that put in the water, you get so many light flash for that. This is a way. And this is a volume integration. Then the other one is, how can you make this sustainable so that it lasts for a very long time? So not only make a big ball, make a small balls, many balls in the volume. So in the water, you're floating like that. There's many things moving inside. But this whole ball is packaged. As long as no water infiltration, you're fine. So outside, if anything, this debris grow on that, it does not affect the action inside. So this is the ball 3D design for that. And then in the ocean wave, it goes very slow pace. Can you accelerate that? So we use the pendulum structure. We'll be able to accelerate the things, so you'll be able to improve the output performance dramatically, because you accelerate the movement. Use this pendulum structure here. Even the water strike once, this thing can oscillate for many cycles for that. So this is the way we develop for high output. And if you struck this one, this pendulum structure oscillates for many cycles, and we can get a total energy conversion efficiency 28%. This is at a low pace. This number is phenomenal. Okay, so you have this one, you can integrate across the board, you'll be able to have this phenomenal performance for that. So we have to do everything ourselves, because there's nothing available in literature we can look. So we have to do this with our team. So this is 28% efficiency at the beginning. Then, did you get any success? Yes. We'll put in the ocean. You see the ocean, have the ocean wave there? We can be able to generate per cubic meter of water, peak power is 80 watts. This is measured. On average, it's 13 watts per cubic meter. Traditional technology can give you about 5 watts. So even this number is 2.5 times of traditional technology. Even they have developed this for centuries. But this is the beginning. From an idea to today, it's only 6-7 years. And it works. They make this light tower so power. So the battery for power, this light tower, can be systemically charged by this water wave energy power generation. So this is the beginning. It shows you see the life for the future. Remember, in the Faraday's time, when he do the electromagnetic generator, he give very little out power. People say, what's use of this one? And today, all the power needed for that. It's a new principle, new science principle, invention. In the future, we're going to have a lot of things to be reborn, to be exploited as well. So I think this is a beginning for this one. We demonstrated recently for that. You see the box we made. So in the future, say how much power is generated. I just use a simple example. And if you have a surface area of the ocean, of like a Beijing city, and use 1 meter depth of water, the power generated is 20% of the power consumption for China. But for ocean, it's a lot of unused space. It just sways there. Gravitation is there, right? But gravitation is always, also this is sustainable. Day, night, continuous. Evening is better because we have this, or evening we have the moon motion here. We can this better. So there's a sustainable, constant, independent weather. If you have a solar, today is a good day. Like yesterday was not a good day. Unpredictable, unstable, and very hard to integrate the grid. So if this one be made possible, we can integrate the power grid for other things as well. So I predict this is the blue energy dream in the future. We're going to work very hard toward this dream in the near future for that. Okay. So this is just show you the way we do it. All right. What's the solution? Called hybrid. So we have solar, we have wind, we have the water wave energy called blue energy. 3 can be integrated together, form an integrated approach for sustainable development of humankind. I think that's a possibility now. I wrote the first article in 2009, proposed this idea called hybrid energy. Today, slowly, we're going to push that, and hopefully one day we can provide something really, truly innovative for the sustainable development of energy. See, energy is what we need. Well, this is an unstoppable challenge to humankind for many, many years to come. Okay, so this is hybrid energy things for that. All right. So looking forward, we first invented nanogenerator in 2006. People use piezoelectric effect. 2012, we invented trouble-electric effect. Can be a nanogenerator. Up to now, we show that it can be a small power, can be a cell power sensor, and can also measure fundamentally liquid and solid interface charge transfer. It can also be utilized for what? For large-scale blue energy. Even we are on the way to do it. But I think anything need time, need investment, and need also a community. We need an international community to do that. Even now we have about 16,000 scientists worldwide, but it's still not sufficient. And something come over here. People see the hope, all right? As a result of this one, I think we're going to have a roadmap for the future to come. We have a lot of work to do, but I think with the recognition of this Global Energy Prize, we are very excited. I think we can achieve the goal. We'll be able to deliver something to humankind for sustainable development for our planet, especially zero carbon emission. Zero carbon emission is good for our climate change, okay? So this is my summary slide. Of course, I have some online videos. Some of students can take a shot of the screen. They can view the YouTube videos. They'll be able to understand these things better. And hopefully, most students, younger ones, can join this one to co-develop, to collaborate, and also explore the unknowns, something we don't know before. And that's what the science is about. So these things belong to humankind, to the whole globe. I hope we use our limited energy to start something new. Okay, of course, we have developed textbooks and other things for the field. Okay, this one move. Anyway, I just finished my talk. Go back. All right, and thanks very much for giving us the prestigious award. And I hope for our non-conventional approach provide an unconventional way for energy, for future energy. That's what science is about. Thank you very much.
Thank you, Professor. It was a very fascinating presentation, and I hope we can use your presentation to make it available to our students.
It's there in the machine. Yes, I can give you a copy afterward.
Yeah, we need it. I was mostly fascinated with your first part when you explained the theoretical part, which is very important for students, I'm sure.
Exactly, because a lot of cases students are looking for what you can use it for, but they are unable to explore the underlying physics, chemistry, which is, as long as you get the answer in this one, they can quantify, also helpful for the design, as well as the future, other predictions. So I work both theory and experiment.
Yes, thank you very much. But I think there are some questions from audience. Please. Лучше сразу все на английском.
Okay, my name is David Zezin, Department of Electronics and Nanoelectronics, Associate Professor. So one can say that solar cells is also the future of our energy, as it's much more efficient than traditional fossil fuel energy. But then we must take into consideration all the energy that we spend to produce solar cell. So if we take all the energy that solar cell produce during its life cycle and then divide it to all energy that we spend to fabricate solar cell, we will get a number really close to unity. So the question is, what is produced to consumed power ratio for your technology?
Okay, we did a comparison, like such as the performance of our technology compared with the solar and wind energy. Here's the number. We just consider for 1 meter of square areas, 1 meter depth of water. For per year, we can generate 400 kilowatt hour power. That's the power density. For solar, if you use 20% efficiency, 1,100 hours sunlight illumination, we can get 275 kilowatt hour. So ours is 33%, 30% higher than solar. And solar has been around for 80 years, at least. Ours just be 10 years or so it's a short time. And for wind, this is much more superior than the density as well. So I think also we did a cost evaluation. We compare with nuclear energy, solar energy, wind energy, all this existing power. Ours at the low end because we use organic materials, like FEP, PTFE, those organic materials. So the cost is low. And I do not have exact calculation to answer your question compare because we are just at developing. But from the number I have now, the performance will be much more superior than those ones. So we open mind, we hopefully can further improve the performance and further lower the cost. So in the future we can deliver something from the performance point of view, outplay of the energy you put in for fabricate for that. I think we should be able to do that. Good consideration. Thank you.
Thank you. Maybe there are other questions? Yeah, please.
Nice to meet you. My name is Pasar. I'm a third-year student of radio engineering faculty, and your speech was very useful for me because we have two of your direction, like bioengineering direction and radio engineering direction. And my question is maybe too global, but is it possible in a future perspective to cooperate Moscow Bioengineering Institute and your Peking Institute to create maybe new faculty or direction to study our students to this direction of future engineering?
This is a fantastic question. Thank you. And two ways to answer your question. Number one, we are open, more than welcome you, students, short-term, long-term. You can pursue a degree with us. You can have a 1 month visit, 3 months visit. We are open. We can provide necessary financial support for student exchange, for scholars exchange. We are open. So already talked to the president just before the ceremony, say, how about we start some international collaboration, student exchange, and you just asked me the right question. I was talking to the president before the ceremony. Yes, absolutely. So number one answer. Second one is that this invention covers a lot area, from biomedical science to wearable electronics, to Internet of Things, smart cities, from environmental protection as well security, for long-term energy need, from ocean exploration. You name it. It's a new principle invention. It's a platform technology you'll be able to apply to many areas beyond my imagination. So we need a lot of young people like you to join in this field. And that's why today I'll talk about the science. I hope you don't feel it's boring, but scientifically new. Second, technology new. Future will be commercialized new. We'll hope to have a major society impact in the future. So do contact us for the collaboration. Yes.
Here is the first student. First student to come to you.
Yeah, absolutely. We'll do that. We'll follow up. I have the contact information for the lady. She is the international relationship. Yeah.
Thank you. Any questions more? Please.
Oleg Mulakanov, Electromechanical Department. Thank you for your inspiring presentation. I have a question for you. You said that the device is based on triboelectric effects, so it's based on friction, as I understand. So what about friction losses?
Yeah, excellent question.
Because you said that the efficiency is quite low, actually, for the wave generator. Is it because of the friction losses or something else?
No, it's low compared to what? Because it's such a low-grade energy, the energy conversion efficiency is all low. Even go to class technology, they are unable to convert such a energy into powers. So you talk about robustness, right? Robustness. We have a number of ways to solve it. Number one, we find a way. If you have a friction, put in some grease there. I thought this is going to destroy my device. I'm going to do that. In contrast, if you put a low permittivity oil there, it enhances the performance. So it can much more extend, number one. Number two, you don't have to do this grinding all the time. As long as the charge is on, they can last for hours. They can freely rotate with the power generation without continuously rubbing one against the other one. So that can improve the robustness. And the other one is that new material design, surface modification. The third one is put some protection layers. So all this engineering approach, we have explored that. We can much more expand the lifetime of service. And like the shoes that we made, we can, if you do 10,000 steps a day, our product lasts for at least for 3 years. So for design, but of course we are unable to move there for lifetime, let's say 50 years. So, but in a process, so we do consider that is not a continual rubbing. That's the mode. Some of the just contact mode, no, rather than sliding mode. So different mode conjunction, different material conjunctions, as well surface protection technology, all has to be explored and under development.
Thank you. In fact, I have a similar question about efficiency. When you talk about efficiency, about 28%, so I can understand how you measure the output power, but how do you measure the input power? What is an input power?
Oh, this, for example, if you have input, you have a micro tricking. That's you can calculate how much power, energy you input for that. But this change things, they can oscillate many cycles. Every cycle generates power. So if you collect all the things together, we'll be able to reach 50 to 85% efficiency. We measure that. So in some cases, the efficiency is really good. But in contrast to the electromagnetic generator, sometimes the frequency is not high enough. So the voltage is so low, only half volt or 0.3 volts, unable to operate a rectifier. So unable to deliver anything. That's why we are not just do whatever electromagnetic generator can do, is to do in an area it does not work, our thing will work. So we find complements rather than so killer application. Rather than say, well, okay, you can do, we can do that, but the efficiency is not as good as EMG. But we find an area EMG unable to do, but we can.
Yeah, that's great.
Yeah.
Thank you. We have some time for more questions. If there are any, maybe we should stop now with the. Thank you very much. Thank you for your presentation and for your answers. And fortunately, we have now 3 presentations, and now we are ready to switch to your presentation, Mr. Любивое Popovich. Is that right? So please, I would like to say, floor is yours, but just take your presentation and switch on your microphone, please. Thank you. Yes, press.
I have to read because my English spoken English is not so good. Thus, I will read my presentation.
Towards the other
Okay.
way. Towards the other way. The receiver, the other here. This one.
This one.
This
Okay.
one.
Okay.
Forward, yeah.
Okay, this one.
Long distance communication.
You must have you.
Point there.
Let me check.
You receive it a little bit distance.
Пожалуйста, помогите нам с презентером. Вот, работает, спасибо. This one. Forward.
This one. Okay. Electric power distribution networks of contemporary large cities all over the world contain inter alia a certain number of high voltage and extra high voltage cable lines passing through the urban and suburban areas. In these areas, as is well known, there are also many other metal installations typical of urban surroundings. Distribution cable lines, together with the surrounding metal installations, share the same streets and sidewalks. Because of such a narrow corridor, the surrounding metal installations are affected by the fluctuating magnetic field that is created by the currents in the cable lines. This field induces a certain electromotive forces in each of the surrounding metal installations. In this way, each of the surrounding metal installations, grounded at both ends, spontaneously forms one electrical circuit, whereas all of them form an underground electrical network with many inductively and conductively coupled elements. Each of the induced currents creates its own fluctuating magnetic field, which acts in such a way that reduces the currents in other surrounding circuits. The problem of determining the effects of their interaction appears as a consequence of the fact that many metal installations are situated under the surface of the ground. Because of that, their constructive characteristics and special positions cannot be visually determined and verified. In many cases, even the total number of these installations is uncertain or completely unknown. For a better insight into the problem, let us consider the currents appearing during a ground fault in a high voltage substation located in urban area. The main ground fault currents fraction in that case are shown in the next figure. During a ground fault in a high voltage distribution substation, large currents and reduced potentials appear in places where they normally do not exist. In the place of the ground fault, the fault current leaves the phase conductor and returns to the power system by using all available paths. Because of that, a ground fault current in a high voltage substation divides into many mutually different flows. Based on this figure, we can see that two fractions of the total ground fault current leave the power system. One of them is dissipated into the surrounding earth through the grounding system of the supply substation, while the other is induced in the metal installation surrounding the feeding line. Because of that, both of these fractions can be dangerous and harmful in the immediate surroundings. The current returning only through the earth, i.e., produces all potentials and potential differences, touch and step voltages that are relevant for symphytic conditions within and in vicinity of a high voltage substation. Besides that, when we correctly determine this current, it becomes possible to put the grounding problem of the considered high voltage substation into realistic frameworks. However, for this, it is necessary to have methodology for cables taking into consideration the inductive influence of all surrounding metal installations. Since the mutual separation of the currents I occurs and II occurs along many external electrodes, mainly sheets of the outgoing middle voltage cable lines, and under the surface of the ground, none of these currents can be directly or indirectly measured. The situation in a similar during a normal operation condition. Currents induced in the surrounding metal installation reduce the part of the underground on the unbalanced current that returns into the power system only through the ground. Because of that, instead of the intensity of the spacious electromagnetic field that is formed around and along a cable line is also reduced. As a final result, we have that the need for the production of reactive energy is in its transmission through the transmission network, and the high voltage and extra high voltage cable lines themselves are decreased. Of course, the reduced capacity released in this way can be used for increasing the transmission of active energy. However, in order to know exactly how much that increase can be, it is necessary to have a methodology that enables taking into consideration the inductive influence of the surrounding metal installations. Additionally, the voltage induced in any of surrounding metal installations can endanger the safety of the public and field worker who maintain this installation. Also, induced voltage can provoke corrosion on the surface of the pipelines and other subsequent, also undesirable consequences. Because of that, it is necessary to have a methodology that enables taking the value of the determining the value of the induced voltage for each of the surrounding metal installations. However, if we want to calculate induced voltage in any installation belonging to the mentioned underground network, we have to know the complete equivalent circuit of this network. Thus, for the beginning, let us assume a high voltage cable line consisting of 3 single core cables with all 3 sheets grounded at both ends and with no applied cross bonding. Also, let us assume the most general case from the standpoint of their space position, as is shown in the next figure. Oh, what? Yes, this is it. However, you can see this is the simplest case. However, in the practical condition, different metal installation, like they are sheets of the different type of other cable lines, neutral conductors of the low voltage networks, steel water pipes, and foundation grounding electrode of the relatively new buildings surround each distribution cable line. Some of them are insulated toward the earth, whereas some other are in direct on continuous contact with the earth. Through the mandatory terra-neutral grounding system in low voltage networks and consumer installation, some of them are interconnected in each of the buildings arranged along the streets, whereas some others are interconnected at middle voltage through low voltage and high voltage through middle voltage substations. As such, independently of their basic function, these installations act as additional neutral conductors of this cable line. Thus, if we perform a simulated ground fault and assume an arbitrarily large number of surrounding metal installations, the previously presented equivalent circuit should be supplemented as shown in the next figure. This equivalent circuit is complete from the standpoint of the number of its elements, but is not without any idealization and approximation of the real electrical circuit. The fact that some of the metal installations are grounded at certain places has been disregarded. However, this fact is not important because we analyze only the induced currents that, as is well known, circulate only in the axial direction through the conductors, and as such cannot produce any potential and on them toward the earth. Also, due to this, it is not relevant whether these installations are insulated or not. Then, the mutual spatial disposition of surrounding metal installation, including the considered cable line, is not important as well. This is because of the following facts. Based on this equivalent circuit, can be observed that the currents in any of the presented circuits contains a cumulative effects of the inductive coupling with all other presented circuits. You can see many circuits. This is the influences. This fact is utilized to solving the problem of the deficiency of many relevant data by measuring the currents in only two of the cable line conductors. Based on the measured values of these two currents and the analytical part of the methodology, it is shown that any other data about the surrounding metal installation and are not necessary. All of them are implicitly involved through the values of these currents. This is the currents on the top of the equivalent circuit. The analytical part of the methodology is based on the introduction equivalent conductor substituting all surrounding metal installation from the standpoint of their inductive influence. This is the notation. As we can see as we have seen, the complete equivalent circuit is composed of self and mutual impedances of all surrounding metal installations and sheets of the considered cable line, including the phase conductor carrying the test current. The presented analytical expression for determining these impedances are based on the Carson's theory of current return path through the earth. This is the symbols. As can be seen, the induced voltage can be determined if we know the values of the inducing current and mutual impedance between the equivalent circuit. For obtaining an induced current for that can be measured in the case of cable line with cross bonding, it was necessary to introduce in the test circuit one more phase conductor, as is shown in the next figure. As you know, the cross bonding is generally applied nowadays, so that main number of high voltage cable lines are with cross bonding. This is this situation. Only measured quantities are circuits through the phase conductors by amperes. As can be seen, the additional phase conductor is connected at its ends in such a way that it represents an additional neutral conductor during the measurement. When the presented this connector is open, the measured circuits allow us to determine only the inductive influence of the surrounding metal installation. However, with the aim of simpler subsequent calculations, it is more convenient to capture the inductive influence of the cable sheets as well. You can see this connector. When we introduce an equivalent circuit, the considered cable line prepared for the measurement can be presented as a relatively simple equivalent circuit shown in the next figure. Yes. previously given equivalent circuits is much more complicated than this one, but it is reduced by introducing this equivalent circuits to this one. Based on this one, the previously presented complete equivalent circuit, it is obviously that the arbitrarily large number of the unknown induced currents and is substituted by only one induced current, II. Also, numerous known and unknown surrounding metal installation, including shields of the considered cable line, are substituted by only one equivalent circuit. Conductor, but only one equivalent conductor, or circuit maybe also. This conductor has to satisfy the condition that currents IT, I1 and IE remain unchanged after its introduction. This is the conditions of equivalency. According to the simplified circuit, this condition can be expressed by the following system of equations. Thus, all previously shown circuit can be expressed only to these equations with unknown quantities. The analytical expression for the impedances of phase conductor are well known and presented in the next circuit. They are presented in these equations. This is well-known expressions based on the Carson's theory of current return path through the earth. Then however, for solving the previously presented system of equations, it is also necessary to have the analytical expression for the self and mutual impedances of the introduced equivalent conductor. In general, it depends on the geometrical shape and the cross section and the spatial position of a certain conductor. Therefore, the following question was posed. What shape should it have, and where should the equivalent conductor be placed? The partial answer has been found in the previously presented system of equations itself. This system of equations becomes solvable only under the assumption that the equivalent conductor has only two relevant parameters. However, any conductor imagined around and along the considered cable line has to have at least 3 relevant parameters to be completely defined. Because of that, the previously determined condition can be satisfied only by the conductor imagined in the way shown in the next figure. Yes, this is it. This cylindrical conductor surrounds all conductors of the considered cable line along the whole length and substitutes the inductive influence only of the surrounding metal installation. It has been used for developing the first version of the presented methodology. However, the equivalent conductor imagined in the finally developed methodology is somewhat different, as shown in the next figure. The additional phase conductor in this figure is marked differently, lighter shade, to indicate that it serves as an additional neutral conductor for the purpose of the necessary measurements. Thanks to the line model format in such way, the necessary analytical expressions become known in advance and are presented in the next slide. This is equations that gives relationship between the parameters of the desired equivalent conductor. On the basis of these expressions, the measured currents IT and I1, the previous system of 2 equations can be presented in the following manner. Since the presented equation gives the relationship between complex quantities, it can be presented as a system of 2 equations in which RE and IM represent the real and imaginary parts of the given equations, the given expressions. In this system of equations, according to the previously given analytical expressions, the only unknown quantities are the longitudinal resistance and mean radius of the introduced equivalent shield. Instead of equivalent conductor, we obtain equivalent, we imagine an equivalent shield. When we determine these parameters for obtaining the actual reduction factor of the considered cable line, we can use the well-known analytical expression for the reduction factor of the cable line consisting of only one single core cable. Thus, we finally obtain the following relations. Yes, this is the file. we obtain simultaneously the resulting screening factor. This is key, which express the inductive influence on the surrounding metal installations. Is presented also together with the expression for the reduction factor. The presented analytical procedure can be explained in the way that is somewhat nearer to the actual physical phenomenon by using the analogy with some kind of transformer presented in the next figure. Yes. Thus, previously shown equivalent circuit can be presented, arranged in such way that represents some kind of transformer with primary turn and many secondary turns. The condition for the equivalency between many secondary turns and only one equivalent secondary turn is satisfied if the value of the resulting magnetic flux remains unchanged. You can see on the next figure. Thus, previous circuit is substitute to this one very simple circuits. All other metal installations, including the sheets of the considered cable line, are involved with this only one equivalent sheet. During normal operation condition of an cable line, we have inducing circuits, inducing currents in all three-phase conductor. In that case, the total inductive influence on an arbitrary surrounding metal installation can be determined by substituting the voltage or current, but superposing the voltage and current induced by each of the phase conductor. That each of the determined induced voltage by the presented procedure have to be superposed with the other on the same way determined influences or induced voltage or currents, depending what you want to have. Then this transformation reduce the problem of determining the series and subsequent impedances of the cable lines to the simple case from the standpoint of the necessary calculations. This is the case when only the considered cable line exists, only the considered cable line exists in the whole surroundings, and when the cross-bonding technique is not applied. But with these transformations, we obtain data for the cable line in normal operation conditions. but in such a way determining the shields of the cables include the influence of the surrounding metal installations. For the reason of increased security, the series impedance should be calculated using the data about the parameters that the equivalent shield that corresponds to the single core cable that is under the smallest inductive influence of the surrounding metal installations. Because we now have three single core cables, they are different positions toward the surrounding metal installations, and we have to determine for each of them the influence of surrounding metal installations, and by comparing this, we can determine this one with the lowest influence of the surrounding metal installations. And this data is most secure for calculation of series impedance of cable lines. For the same reason, the sequence impedances should be calculated by using the data that corresponds to the single core cable that is under the largest influence. This is the impedances that we use for calculating the ground fault currents, and for the safety reason, it is better if we assume somewhat larger influence because on the side of larger security. Finally, we have applications of the methodology, determining the actual reduction factor of the considered line, determining the anticipated ground fault current in the supplied substation, determining the resulting screening factor, the influence of any of surrounding metal installations seen separately, the more correct procedure for testing safety condition in a certain high voltage distribution substation. This is a separate problem, but is solved by using this methodology. During normal operation condition, determining the actual power transfer capacity, determining the resulting screening factor. Finally, quantitative effects. Quantitative effects of surrounding metal installation depends on the degree of urbanization, but on the basis of the experimental measurements performed in the power distribution network of Belgrade, we obtained that it can be to 40%. This is pretty large enlargement. But the influence on the ground fault current distribution is much more large. It is shown that current passing only to the ground is 5 times less than was considered before. This dramatically changes our perception about this problem all over the world. people think that this problem 5 times greater than it really is. The same situation is with the influence inductive on any one of surrounding metal installation. That's about 5 times less. In the area with high urbanization level. Thank you for attention.
Thank you very much. Thank you for your presentation. I think it was clear to everyone, and I'm glad that your topic is once again close to some of areas in which our university works too. And I'm sure that we may find some questions to you. Yes. But I should say that special thanks from me to you for your last slide, that you demonstrated the results, the practical results of this theory. You managed to simplify the problem, to take into account everything in a very simple model, and then you demonstrated that practical experiments proved that this theory.
Yes.
That's great. Thank you.
Yes.
Yeah?
I may say we have a big problem. I am from power industry, and Belgrade have a big problem of high level of ground fault currents. Because of that problem is very severe, and I was devoted to this problem. And as a result, this methodology. Or this problem, I can see.
I see that you are working in a power distribution company.
Yes.
Thank you. So, other questions? We invited some persons from the high voltage department. Yeah, Parol, please.
I will not hear good. I didn't hear.
The inner resistance.
Resistance of the ground.
Resistance.
Resistance of the ground.
Very small, about 0.225. 0.2 to 0.5.
But there is any requirements how to choose the resistance, or in your network, in experiment, what was 0.2 or 0.5? Mostly in Belgrade, how was the network?
But our ground fault currents are about 20 kiloamperes. Thus, problem is obvious. Never doesn't matter of the low ground impedance. Problem appears. A big reason for successful managing to solve the problem is the influence of the surrounding metal installations of so large ground fault currents.
Thank you. I have another question. And the shield of the cable line, does this result influence on the calculation of the shield of the cable? Maybe the shield has to be bigger or smaller? Or there is no correlation?
My hearing is weak.
Kako shield utječe na to povećanje ili shield, kako shield utječe na to povećanje ili smanjenje, kako utječe shield?
Yes, dramatically. Reduce on the reduce 90% to 95% the ground fault current passing through the earth. Maybe more and more.
Okay, thank you very much.
Thank you for your questions. So, any other questions? Maybe next time. Once again, we will use your presentation and distribute it to the students. Thank you very much for your presentation. And today at our academic colloquium, we have a third presentation from Professor Jchun. Now it will be devoted to another field, the thermal energy.
Yeah, okay. So good morning, everybody. It's my great honor to have the talk. And so my research, especially for the thermal engineering and how to make efficient uses of an energy, heat, for heating and cooling, and also thermal management. So this is actually my university, Shanghai Jiao University. And in the history, we had good collaboration with your institute. And this university now ranked number 3 or number 4 in China. And so we have a school of mechanical engineering, that's my school. And so this school now listed at the top 19 in the world by QS ranking. So my talk is for the researchers. At first, say something about global final energy consumptions, and what you could see that nearly about 50%, that's heating and cooling. So now if we have a talking of decarbonization, then we must consider at first decarbonize heat. So in China, now we have more uses of renewable energy, and also we consider the more uses of waste energy or waste heat, any kind of natural resources. So in this case, now China, we have the policy 2030 carbon peak and 2060 for carbon neutral. So in this case, now we have a national campaign actually try to make more uses of renewable energy and also try to reduce expenditures of energy uses. So in this case, if we talk broader the sources, we could consider more uses of renewable energy or even ambient thermal energy. And if we have talk of reduced expenditures, any kind of waste heat from industries or even air conditioning waste heat could be considered to be used. So in this case, this low-grade thermal energy, we need conversion and regulation of this kind of low-temperature thermal energy and for the efficient uses for heating and cooling. And also it's related with electrification because now we have more and more uses of renewable electricity. So in this case, I want to say some 3 areas for the thermodynamical researches and also thermodynamical heat transfer coupled enhancement and thermodynamical heat and mass transfer coupled enhancement. So these are actually the 3 categories I want to say. The first is thermal-driven absorption refrigeration. Because when I got my PhD in 1990, at that time, there is a lot of Chinese new industry of solar heating. So in this case, I collaborated with them. And this industry grew up very quickly. So when we have enough solar collector, then we need to consider that whether this kind of solar heating could be used for the cooling in the summer. So in this case, I did some research work for thermal-driven adsorption refrigeration at first. So using silica gel water or activated carbon ammonia and activated carbon methanol, for example. So we developed this kind of system, and especially to make a cycle, because we need to have adsorption process. It's intermittent. So when this adsorption, it causes evaporation or cooling, but another adsorbent bed, you need to heat it to be regenerated, and then you get a condensing. So by these two adsorbent bed, we could make switches. So in this case, to give the cooling function to be continuously. So in the early researches, many people that considered if you have two adsorption betas, you need to consider the heat recovery. In this case, you could use the desorption, the bed with high temperature, so you take some heat recovery to power this kind of adsorption beta for the second generation. So this, we make good uses of temperature potential utilization. This is so-called heat recovery. So my invention is something different. Based upon this, if we have two beds, what you could see that when one bed is finished, the desorption, and you get the pressure at the condensing pressure, while another bed is adsorption, so it works at evaporation temperature, evaporation pressure. So we still have the pressure potential difference. So in this case, I consider whether you could move the vapor from high pressure to the low adsorption pressure bed. So in this case, actually, these two bed, we just make this connection as a, so just before the switching, you move some vapors and direct it to another adsorption bed. In this case, what we could find in the cycle to see that you enlarged this kind of circuit refrigerant. So delta X, the small delta X is actually a little bit increased. So this increase, you will increase the cooling power, and also you will increase COP value for the cooling. So then we made some theoretical analysis to see how this process could be efficient. And then what we could see, especially for the cooling, for the solar heating temperature at about 60 degrees or 70 degrees to power refrigeration system. For the basic cycle, that's a single bed, and then if we use two bed with mass recovery, and even we use heat and mass recovery. So what you could see that it's possible to get this kind of COP value for cooling, maybe increased by 100%. So this is just a very simple with the invention of mass recovery. So you could get very efficient uses of low temperature heat for cooling. So then, in the year 2004, I designed and manufactured such kind of system. And this system just shows that the operation, which is two betas, and so we have the single, one beta with a condenser and evaporate, and just go between these two processes. And we could have a so-called mass recovery, and usually this is powered with solar heating 60 to 85 degrees, and but for the cooling to generate about 10 degrees chilled water, the COP value could be about 0.4 to 0.6. So then based upon this research, we continuously developed so a lot of units and such kind of adsorption chillers and also adsorption ice makers. And also I wrote a book so-called Adsorption Refrigeration Technology, Theory and Applications. And what I found that these mass recovery cycles, now it's commonly adopted cycles for every kind of adsorption chillers in the world. So in the market available, all the chillers, they use our mass recovery cycles. And now, because originally I pay attention how to make efficient uses of solar heating for cooling in summer. But really, that's a problem because in summertime, if it's not a long time, so solar cooling, this kind of payback period could be long-term, maybe 5 or 6 years. Mm-hmm. So then I consider whether it's possible to find industrial waste heat. If you have such kind of waste heat, you could use it for heating, for cooling all the year. Now we have actually data centers. So data centers actually now they have about 50 to 60 degree hot water. Usually the hot water comes to the cooling water tower and you get about 30 to 40 cooling down. And then this water come back and by electrical driven water chillers to cool down to about 20 degrees, and then come to the air conditioner or air-cooled racks for the cooling. So in this case, the waste, this kind of waste heat, now I consider we make changes. So we use this 50 to 60 degree hot water, go directly to the adsorption chiller, and we make 20 degrees chilled water. Then we release waste heat very small to the cooling water tower. So in this case, it's a very good solution for the data centers. Now we are in collaboration with Huawei because they have big demand for this kind of applications. The second thing I wanted to show you that if we consider solar heating or solar cooling, and I invented the so-called variable effect absorption refrigeration. So because originally before, if you have about 85 degrees hot water, you could power lithium bromide water absorption chillers. Usually this is a single effect. But this single effect could be used for solar cooling and waste heat recovery cooling, or even used very popularly for the combined cooling, heating, and power systems. But if we have a look that for the heating sources, if it's 85 degrees and the COP value for cooling is about 0.7. But if we have heating sources 140 degrees, for example, if we have medium temperature solar collectors, in the mid-noon you could generate 140 degrees. So then for the regeneration, you could generate high pressure steam. And this high pressure steam could have a condensing temperature still higher than 85 degrees. So you could have a second time usage of condensing heat. So this is a double effect. So in this case, it's a very popular, it's a single effect, double effect, but we could have a lot of circumstances. The heating source is between 85 to 140. So in this case, originally, there is no suitable cycles, just 130 degrees, 135 degrees, you still use single effect. So then I consider whether we could develop. So in this case, I suggested so-called 1.N effect. Then later, I renamed it as a so-called variable effect cycles. So this solved the problem that we just added a high pressure absorber, HA, and then the second low pressure generator. So by the generation of the high pressure, high temperature generator, the steam vapor pressure is not that high. But if it comes to the high absorption absorber, we could still generate this kind of absorption heat with a temperature more than 85 degrees. So in this case, we could develop such a kind of systems, and then on the normal used system, we just added the right side just by 2 heat exchangers and with a pump to circulate, just to circulate absorption heat to generate the low pressure, the second generator. So in this case, we could create this effect, especially for solar utilization for cooling, for example. So if the heating sources is between 90 to 140 degrees, now we could get a COP value. So depending on the heating source temperature. So in this case, the COP, what we could see from 0.7 to 0.1, 1.08, this is for the 120 degrees centigrade. So in this case, we created and also commercialized this kind of valuable effect lithium bromide water absorption chillers. In this case, we could make good uses of the thermal grade of heat. So for this research works, so I gave some contributions and received the award from the Institute of Refrigeration of UK for J and E Hall gold medal because we developed the new ways for efficient uses to solve this kind of efficient cooling for the air conditioning with adsorption chillers, and also with the International Absorption Heat Pump Conference, Georgia Freedom Memorial Award. The second thing I want to say, the first is for cooling, the second I'm consider heat pump, upgrade the temperature. If we have a waste heat, and if you, whether it's possible, you upgrade and then to become it useful again. So this is so-called high efficient upgrading of low temperature thermal energy with heat pumps. So to first say something about air source heat pump. So this is my contribution for the commercialization in China. And so because heat pump is very easy, the working principle the same as the refrigeration. But now we just take the heat from the waste heat, from ambient heat by the heat pump, upgrade to the high temperature. So usually if we input a W and we absorb QC, and then you release QH, and the COP value, QH divided by W, always higher than 1. So possibly you get a 3 or 4 or more. So in this case, if you use this, it will be possible that because the demand, if you have more high temperature, you could meet more demand. But if we consider the heating sources, the lower the temperature, you are more rich of the heating sources. So just by the heat pump, we could move the line and to get the more overlap, try to get the uses of the low-grade thermal energy by heat pump, and then for the heating uses. So in this case, 1 kilowatt heat electricity, if it's electric heating to 1 kilowatt. But with a heat pump, 1 kilowatt, we could absorb, for example, 3 kilowatt from the air source, then you release 4 kilowatt for heating. So this is a concept for air source heat pump water heaters, and with a COP about 4. So then with this kind of concept, I need to commercialization for this, and then develop this kind of infrastructures. And I made commercialization in the year 2003. That's the first manufacturer in China. We use air source heat pump of water heaters. And 2011, we consider this kind of air source heat pump with hot water. We could use hot water as a hydraulic systems for the heating of the space heating of the buildings with a fan coil unit. And 2018, I did another research because I consider air source heat pump could generate hot water and space heating, and whether it's possible for steam generation. So this third is about steam generation. That means to nearly to get the temperature lift more than 100 degrees centigrade. In this case, we tried the possibility to replace coal-based boilers because for the decarbonization, it's so important. So in the year 2003, at that time, because there is no commercialization of such kind of units of air source heat pump water heater, because this heat pump water heater, you need to consider that temperature changes from low temperature to high temperature, and also seasonal climate changes. So at that time, there is no regulation, no electronic expansion valves, no invert compressors. So at that time, I first proposed a dual capability tubers to make the switching regulations depending on the pressure difference. So in this case, to make this kind of product into commercialization. And then later, we tried thermal expansion valves, and also in combination with capillary. And after 2012, because electronic expansion valves that's matured and it's a market available, then we could make good use of this kind of expansion devices. So in this case, this technology developed, and also we developed also some researches for the hot water tank, because we use the heat exchanger into the hot water tank, and so normally due to the temperature difference and so hot water usually at a high place and low temperature water is down. So in this case, we need good design of this kind of heat exchangers to spare, because when we're doing this, originally before we're using this kind of circle heat exchangers, but then we consider maybe heat exchangers used for the high temperature, not that important. So then we use this kind of chip and try to reduce the copper tubers. In this case, make these changes, and then the company will be very happy, because if we do that, they will save 100 RMB yuan. So this is really benefit for the company. If we do not make this design, efficiency is nearly the same. So in this case, this is based upon the requirement and also in consideration of the company benefit. And then in the year 2011, we started also new research work for the hydraulic system with a small temperature difference fan coil unit, because originally before the heating with a fan coil unit, so actually they need 45 degrees hot water and to heat. But I say we need only 20 degrees for the room space heating. Why you need 45? If you reduce to 35, then the efficiency of heat pump will be increased 30% or more. So in this case, I proposed such kind of concept, develop the system just to make the changes of the terminal, the heating terminal. We call it small temperature difference fan coil unit, just by the increasement of heat transfer alpha value and also increase of heat transfer surface. So in this case, we use actually enhanced heat transfer fins and also reduce the diameter of the water tubes. So in this case, we make these changes, and then to make 35 degrees hot water possible for heating, for space heating, and also I tried this make comparison of, for example, cast iron radiator. That's quite popular in China, especially in North China. And the radiator for heating is normally used in rich families. And we proposed this small temperature difference fan coil unit, try to solve the problem and also to reduce the cost. And then we did a test of this kind of unit and with the auto air source heat pump in Korea industry, because they have auto testing simulation at minus 18 degrees centigrade with snow. And then we make the test inside the room, make comparisons of these 4 type of heating terminals. The result just shows our small temperature difference fan coil unit is more efficient and very close to the radiative floor heating, but it still has a very good function for the cooling in summer. So in this case, based upon this concept, now we have a Chinese standard to promote such kind of technology. My third talk is for the air source heat pump for steam generation, because in China for decarbonization, coal-based boilers, that's very popular. So in this case, we made investigation to see that thermodynamic cycles, if we consider, so especially for the input temperature below 40 or 50 degrees centigrade, and it's not possible to get output 100 degrees or more. So, but this is air source heat pump for steam generation. We need this kind of technology. So at first I did some research work to use water as a refrigerant for the heat pump. And so I think we have a lot of waste heat at about 80 degrees centigrade, but if we could, by heat pump, to lift it to 120 to 150 degrees centigrade, it could be reused in the industry, in the process engineering. So then we did this kind of heat pump using water or steam as a refrigerant. And this just shows, so the COP value could be between 3.5 to 5.7. So this just shows if we have temperature increase from 80 to 120, the COP value is about 4.51. So if, in this case, if we do have 80 degrees with heat, then it will be very good to use such kind of technology. So when it's realized, so we are very happy, so students also very happy, so we have realized that the water to transfer actually 80 degrees, at that time water is at a vacuum pressure. And then to 120 or 130 at a high pressure. So in this case, we need to overcome a lot of difficulty for the compressor and also the system. So when this is available, then I come to the industry, whether you need. And then what I found, the industry said, Professor Wang, we need this technology, but we need heating by steam vapor. So in this case, that means because it's very popular, because the boilers, they generate steam vapor for industrial heating. So it's very easy, and steam is a very good carrier for thermal heating. So in this case, we need to make some changes. So these changes we developed the 3-stage, actually cascade system, and from 2 stages, we get it from heating from the ambient and to get hot water heated to the mid temperature. But then the 3rd stage we use directly. So this flash vapor, because we could get about 80 or 85 degrees, but at the low pressure, but it comes to the water vapor compressor directly to generate high pressure steam and come to the steam pipeline. So in this case, it's very simple. And we developed some technologies of the compressors, try to make it more efficient and more stable. And then we had a first example to use air source heat pump for steam generation in a Chinese liquor company, or this is a white spirit. I think the concentration of alcohol is more strong than vodka. And what we made maybe about 65% of alcohol actually for the concentration. So in this case, they need about 120 degrees, and we using this heat pump, air source heat pump, so also with in collaboration with some part of solar panels. So this is developed and then tested, and then now it's already operated for 4 years. And based upon this, now this company and Shanghai Jiaotong, now we establish a new company to build such system, because we find that they have a great market in the future. So the second, what I want to say that for the low temperature thermal energy upgrading, how to get more efficient. So this is related with heat transfer, heat mass transfer actually. So because if we consider waste heat utilization, and it's normally if you take waste heat, then temperature will go down. But for our heat pump, evaporation or condensation, it's a fixed temperature. So in this case, how to reduce this kind of temperature heat transfer difference, and then to increase its efficiency. So in this case, for example, what we developed for the heat pumps, for example, we could develop a last double evaporation and condensation systems. This is for the waste heat recovery and also to generate upgrade heating. So in this case, what we could find to compare with the first picture. So the red line and the blue line, this is the A layer, this is heat transfer losses. So now we could reduce. In this case, you could increase the COP value. And then we demonstrate with a 10 megawatt permanent magnet synchronous frequency conversion centrifugal heat pump unit. So this is the first example that we try to upgrade waste heat from 30 degree to about 60 degree for the building heating with a 10 megawatt. And the COP value is 6.67. And also the payback period is very short. It's 1.7 years. So when the customer uses this for the first year, then they are very happy. So then the second year, you made another, ask us to develop another 5 units. So in this case, total 60 megawatt that's used from industrial heat, and then we upgrade and for the building heating. And also another project is for the absorption heat pump. We in China, because in North China, especially for the winter heating, we consider that's a combined heating and power systems. So usually for the winter heating, in the winter, we take steam from the boilers, of coal-based boilers or natural gas boilers. So for the condensing, to get the return water from about 50 degrees, increase to about 105 degrees. So just by steam generation. So this is legal. But this actually what our project, because it was in the 1950s. And after so many years, this is in Lanzhou, Xigu, electrical power station. There are more and more residential buildings. So now people living standard increased. So in this case, in the winter time, they do not have enough power used for the heating. If they take more steam, then electricity will be lost. So in this case, we need find some solution. So what we proposed is try to find heat from the cooling water tower. So electric power station, they have cooling water tower in winter time still about 30 or 35 degrees centigrade. And then we try to combine with the lithium bromide water absorption heat pump. Try to make good uses of 35 degrees with heat by absorption heat pump upgrade to about 80 degrees. So in this case, the second figure, just you see laser line steam and then returned blow line. So these areas reduce a lot. This is actually we call it in-choice dissipation reduction. So it's a kind of new design, and also because this project is too big, actually this project that's 290 megawatt. So it's a very good contribution for the local wind heating. And in consideration, this kind of machine absorption heat pump capacity is so big. So at last we decided each unit with about 60 megawatt. So in this case, 60 megawatt, and then we need manufacture in the industrial, but long-term transportation there, and then install there, connect again, and then to build the full factory for this kind of waste heat recovery unit. And this just shows 290 megawatt, and we recover waste heat about 125 megawatt. And so in this case, we have a COP value, 1.77. That means nearly about 77% waste heat. Actually, for the heating from 50 degrees to about 80 degrees, so we take 77% from the cooling tower. So this is a big, very good contribution for this project. And not only here, but also we explored this project to Singapore. So because when I had a vacation there, I did a speech, and then attracted the local company, so-called this company is so-called Sembeco, and they asked me, Professor Wang, we do have this kind of project that the waste heat from 110 degrees, and so they have 2 times recovery, and then at last released to the sea. So then they have a call, the bidding process on the internet, and then they said, so Shanghai Jordan could participate. Then we participate. And then at last, so I introduced absorption chillers, because Singapore, they need all the year for cooling. So in this case, the first stage, we make changes by the absorption chillers. And then this changes a lot if we make a evaluation of the hot line and a cold line. So we get very uniform distribution of the heat transfer temperatures. So in this case, we developed actually the waste heat about 8 megawatt. We get a cooling output of 5.6 megawatt. And so this is actually the payback period is less than 2 years. And also Singapore, their news agency published to say 2 best low carbon energy saving cases in Singapore. So this is actually the one. Actually, that's my contribution. And then also I wanted to say something that a heat pump increments for heat storage. Because now we are considering the more renewable electricity, but it's not stable, so we need to consider energy storage. So only that most of the people consider the battling power stations, but very less to consider for thermal. So in this case, we think that the thermal storage is so cheaper and also so safe, but we need to build it into the demand side. Originally for the electric power generation with the battery for the power energy storage, that's actually generation side. But now we considered we have energy storage in the demand side. It's inside of the cities, inside of the residential buildings. So in this case, now I am responsible for the larger scale heat storage, regulation of thermal energy with heat pump. This is a new huge project in China. And I think we may have this kind of progress. We try to consider by so-called electrical to energy, we call the so-called energy increment storage by heat pump, because heat pump could absorb ambient energy or waste heat. So if we have 1 kilowatt electricity, you get nearly 4 kilowatt heating stored into the storage. But for the output, normally every people think if we have 100 degrees, then you consider 80 degrees, 60 degrees, this is called cascade usage of heat. But I think we still have heat pump. You could also generate 120, 150 degrees for industrial uses. So in this case, by the uses of the heat pump at first for energy increment storage, and then for the demand side at last, maybe still possible energy upgrading with the heat pump. So in this case, we could improve system flexibility. And also in this case, more flexible for selection of heat storage devices and materials. So this is actually my new work. And also for this work, I received International Heat Pump Award from International Energy Agency. And the last, I say something about thermal humidity conversion and control. We pioneered the novel heat pump air conditioning cycle. Try to make air conditioning with energy efficiency 100% increased. So this just shows normal air conditioning, room air conditioner. Electricity consumed 50% to 60% for cooling, but still another 40 to 50% for the dehumidification. So this is the normal uses of air conditioner. This process, you release condensing heat to the environment. So then I made some changes. I think electricity possibly we consider 50 to 60% for refrigeration. But condensing heat, whether we could use this condensing heat and try to be used for the dehumidification. So in this case, maybe 50% of this condensing heat could be used for dehumidification. Then dehumidification will not consume electricity. So in this case, you get the energy efficiency, COP value, 100% improved. So then we developed so-called water-absorbing heat exchangers. Actually, normal evaporator and condenser now is covered with desiccant materials. So when the cooling process, originally for cooling, we need about 5 to 7 degrees for evaporation because actually for air conditioning, 26 degrees and humidity 50 to 60% relative humidity, normally you have a dew point about 15 degrees centigrade. So you need to have a cooling surface less than 15 degrees. So most are designed 10 to 12 degrees for the evaporator at the inside the room. So, but in this case, you need a very low temperature or evaporation. So in this case, the efficiency is not high. So conventional efficiency for air conditioner is about 3.3 or 3.4 and so on. And the evaporation temperature 5 degrees and condensing temperature 52 degrees. This is a Chinese air conditioner national standard. Now I made two changes. Evaporation temperature increased from 5 to 15 degrees and the condensing temperature reduced from 52 to 45. How to make these changes? Because evaporation temperature, now we do not need dehumidification by dew point. We need only the heat exchanger covered with the desiccant. So moisture will be absorbed by the desiccant. And, but for the condensing, so because the condenser and the evaporate, maybe every 5 or 10 minutes, they make a swift the changes of the function. And also air duct changes the direction. So if you make the changes of the functions, so the condenser, originally it was evaporate, and then it's absorbed with moisture. And then when the condensing happened, the moisture needed to be dissolved. This is something like evaporated cooler. So you reduce the condensing temperature. So in this case, we developed the system, and we use a 1.5 horsepower scroll compressor, and then demonstrate because with this kind of system, and yeah, we have a flash, but it's not available here. But actually, we increase COP value from 3.2 up to 6.2. It's nearly 100% increased. So with this kind of increased thing, I need to find an industrial, because original research that's based by the Chinese National Natural Science Foundation of China, just to show this is feasible. And when this is feasible, then I need to come to the company to find the collaborations. So they developed different kind of models. Then at the last, I find the company for, this is so-called MELAC. This is a joint venture between China and Germany. And this company had nearly about 30% supplier for the air conditioning for the train vehicles in China. So because of train vehicles, especially in the metro in China, now it's very popular because in Shanghai, we have nearly about 600 kilometers. And now in China, we have so many high-speed train. So in this case, now we have good collaboration with this. And we already reached the COP originally Chinese standard for this 1.68. Now we also already reached 3.6, so 100% increase. So now we are in collaboration with the company next for the demonstrations in the metrons for train vehicles, and then next for the long distance high-speed train. So this research actually also we need other possibility because we are using this kind of desiccant to handle humidity. And then I proposed some new solutions for efficient control of heat and humidity. So this we created so-called sweeting cooling. And because using adsorbent to absorb moisture, if it's adsorbed by morph materials, for example, so this could be used for the cooling of electronics, because if electronics, the power consumption is lower, then the temperature is lower. During that time, adsorbent could absorb moisture water from the air. So then it's stored with moisture, but when the power goes up, so then the heat will be used for the desorption. In this case, it will suppress the temperature lift. So this is actually the concept, so called sweet cooling. And so we developed this model and then also tried in 5G mobile phone, actually. So my research group, we contributed for the 5G station, actually for the heat exchangers, because they need this, and also for the cooling of 5G mobile phone in collaboration with China Huawei company. And now they told me that we contributed more than 10 million units for the 5G stations for the cooling, and also more than 10 million units of mobile phone cooling. So we contributed, and so now we are pushing another possibility. Actually, with this kind of process, we could reduce the temperature increase, maybe 8 degrees or 10 degrees, if it's a peak time about 30 minutes. So this is actually our research. And then I tried this coated on the 5G mobile phone. So the test is only 1.7 gram of morph materials. And what we tested, that the heat dissipation could be increased more than 10%. And when you run with ANTOTO score, this is to the evaluation of the mobile phone when the young people want to play games. So then performance improvement is about 20%. And also now we are pushing this kind of new technologies, absorption materials, and for the 5G station cooling. And now we already have very good results, and I'm pushing the collaboration with Huawei for the next improvement. And also we did some researches, air humidity assisted absorption thermal battery, because for the adsorbent material, if it's adsorb moisture from the air, it will release adsorption heat. And this adsorption heat will be much higher than PCM, latent heat. So then we did this test, developed some modules, and so in this case we could continuously to get output with stable temperature and a stable heating output. The storage, energy storage density could be about 240 kilowatt hour per cubic meter. So in this case, this just to show that it's could be more acceptable for the thermal storage. And also recently we use technology for the uses of solar-driven atmospheric water harvesting. So this is another new area, right? And what we have demonstrated, actually for such kind of unit, 1 square meter solar collector, we could get nearly about 1 kilo water and 1 sun in daily. And so in this case now we are seeking the more possibilities of applications of atmospheric water harvesting. And also for this, I received some award from the International Thermal Science Memory Award from Japanese Heat Transfer Society, so called Nokayama Memory Award, and also from International Institute of Refrigeration, so called Gustava Lawrence Matter. And also, all research also have some impact in the world, and both for the atmospheric water harvesting and also for the seawater desalinations. And now these will be new areas for our future commercialization. So my summary for this is that actually all areas try to make good uses of thermal energy and to consider heating, cooling, and humidity control. In this case, we need to develop some new series like heat and mass recovery, like variable effect absorption, cooling, lag cascaded with steam vapor, and also the desiccant-based air conditioning systems. And we consider the utilization, try to make good uses of solar energy and ambient energy and industry with heat, or even air conditioning with the heat. So in this case, we developed some new technologies and commercialized. In this case, we could enable carbon neutrality by broadening sources and reducing expenditures. So my acknowledgement to the Global Energy Prize, because I received the award for the categories, new ways of energy applications. And so we developed a lot of facilities and commercialized, and I'm very happy that to collaborate with Chinese industries and to promote some new technologies originally before not available, but now it's popular. And so much thanks to the Global Energy Association. Thank you. Thank you.
Thank you, Professor Wang. A lot of information at the time. As my first impression is, it's very simple. Just take some heat from nowhere and everyone will be happy. But, well, are there any questions to Professor?
Yes, can.
Please.
Thank you very much for your very interesting presentation, especially for your show and practical realization of your very interesting ideas, because for me it's very important. So I have several questions, but first of all, is global. What is, in your opinion, a low potential thermal energy sources is?
So this is a very important question, and now we are considering that how heat pump could contribute for the decarbonization. And I made a lot of investigations. So what I found that we could consider the waste heat recovery, heat pump for the industrial heating, and even the ambient from atmospheric air or ground source. So heat pump for buildings and also for the steam generations. So my estimation is that now for the buildings, normally we need only temperature below 80 degrees centigrade. So this could be 100% supported with a heat pump. But for the industrial heating, at the moment, I would say our technology is available to reach 150 degrees centigrade, if we consider from air source to have nearly about 100 degrees upgrade. So in this case, this heating for the industry actually nearly about 50% of thermal energy for the industry. So in this case, what I estimated that we could get 100% for the buildings, and then 25% actually nearly for the industry, because industry heating energy consumption nearly about 50%, but I could use also 50%. So in this case, the total contribution is about 20% for the carbon decarbonization. So then I got another study that from Professor Jiang Yi from Tsinghua University. He is a member of Chinese Academy of Engineering. So his point is between 15 to 20%. So it's very similar. And very recently, or last year, I get information from Elon Musk, because Tesla now they started the called Master 3 plan, and this is just he made an investigation to say heat pump could contribute for the decarbonization for the buildings, for the industry in total to get fossil fuels reduction for 22%. So in this case, now I'm very sure it's possible to reach 20%. So, but for this carbon neutrality, actually the process still about 30 or 40 years to go. But to replace the current thermal systems, because if new boiler is available, you ask them, please remove it, replace it with the new heat pump. It's not possible, because this boiler needs to work 10 to 15 years. So in this case, we need only 3 time possibilities. So in this case, that if country, the government, and also industry, they work together, and in this case, it will be possible that we have 3 times replacement for the actually fossil fuel-based boilers. So I think in this case, not only China, but also the worldwide, that it's good to see that because just this September or this August, when I was in Paris to attend the International Congress of Refrigeration, I also did a speech for the estimation for the heat pump contribution for carbon neutrality. And now all the communities that said International Institute of Refrigeration should be International Institute of Refrigeration and Heat Pumps. Also in China, I am pushing that Chinese Association of Refrigeration should be Chinese Association of Refrigeration and Heat Pump, because heat pump contribution could be even larger than refrigeration in the next years. So I think this is my answer for this.
Thank you very much. So next question is practical. What do you recommend it for our country? Because we have very cold climate. So what maybe what pair of absorber and liquid we can use in absorber statement? Yes.
So actually, we had some collaboration with the Institute of Catalysis in Russia. And, so Professor Yuri Aristov did some researches and to see, because there maybe they have temperature minus 40 or minus 50 degrees. And he proposed the possibility in the winter time, even the water sources is about more than 0 degrees, they still have about 50 degrees temperature difference. And the heat pump is still possible to go. And now in China, for the North China, we had the lowest temperature about minus 35 degrees centigrade. And it's close to the boundary between China and Russia, actually. And so in the last 10 years, a lot of Chinese industry involved. And because we started nearly about 10 years ago for the electric heat pump to replace coal-based boilers for heating, and especially in North China, because 10 years ago, in North China, the air pollution is so strong that in winter time, this is caused by the coal-based boilers. So then, in Beijing, Tianjin, and Hebei province, that's nearby there, because the ambient temperature will be about minus 10 or minus 15 degrees centigrade. So air source heat pump usually could be using rubber stager to be used. But now it's very popular from Beijing to the south part, and also from Beijing to the north part. So to the north part, that's to the minus 35 degrees. And in this case, the Chinese industry, they made some new inventions of the compressors. And also these compressors, they have some injector system, originally to inject the vapor, and they try to enhance the heating power, especially at a low temperature. And then they find that there are some problems that if the temperature difference is so huge, they need to try to reduce it and then to inject liquid refrigerant, so, or inject the both liquid refrigerant and vapor refrigerant. And then now they found that it's still possible that to be used in that area, and it's already commercialized there. And then also they were pushed by the just the so-called energy US and supported by the energy environment energy so-called spatial foundations, and then they tried to be used in Mongolia. In Mongolia could be about -40 something, so it's also realized. So, but I think -50 is still a problem. That
Yes.
if we can, in this case, we need to consider in combination with GLONASS, because the ambient temperature, if it's so lower, and so if we consider more GLONASS or water sources, then it will be more possible.
Thank you very much.
Thank you.
Thank you for your answers. And are there any questions more? We have some time for questions. Are there any, please?
Thank you, Mr. Wang, for your presentation. It was very interesting. I have a question. What do you think about the traditional scheme of heat pumps, brand-based heat pumps, ground source, taking into account the new technologies of drilling, such as horizontal directional drilling, which allows to make installations rather cheaper in terms of costs, and also it's possible to widen the field of its application.
So this time when I was in Paris, and we really had a lot of discussion with UK scientists and also German or Italian refrigeration people. Actually, in China, because it's the product of heat pump is already very cheap. So, and I'm sure that all this product could be very easily used in the UK, for example. When I visited UK some years ago, and I did a lecture there in the Institute of Refrigeration, I think the climate there is no problem because it's very similar as Shanghai. So it's no problem. But the traditional, the European, the heating, they're using actually boilers or using water, and then have some chimneys. So to make such kind of changes, actually it's not difficult, but the concept of the people need to change. But another thing, the problem that what I found that Chinese product is available. It's not expensive. But if the product come to the UK, you need a lot of technicians, some technical people to install. The labor cost is too high. Because in China, if we buy this kind of heat pump, the labor cost included. But if it's come to the European countries and especially UK, for example, the installed labor cost actually is too expensive. So in this case, actually now I am promoting our Chinese industries, try to go directly to the European countries. And one of Chinese big companies is called Media. And we have Korea and Media and Hera, the three biggest company. And Media already bought one Italian heat pump company. And then come there, design and manufacture and sell. So now my PhD student originally, now he become the CTO, come to Italy to work with Italian colleagues there. But now that company already belongs to Chinese company. So in this case that when Chinese companies come to destination for the customers, then we could reduce the cost. And also, we found that in Germany, for example, they already start enforcement of the use of heating with heat pump. But they still have another policy. So 60% should be supported by European countries. That means if you import from China, the maximum 40%. So because if Chinese product is too cheaper, it will actually cause their problems, but economy. So this is similar like electrical cars. Now Chinese electric cars is very strong in the world, and but now actually it's not from Germany, it's from France. And because Germany actually they are making changes of the cars switch to electrical, but France it seems that they have more difficulty, and then they start some this kind of tax from European, try to increase tax for the Chinese electric cars. So what's at the moment now, I think for Chinese industries or government, we always face this problem if we have good technology, and also, so now it's a market acceptable, but how to overcome the difficulty due to the policy of different countries. So in this case, really, we need to have more Chinese companies going abroad, similar like in the 1990s or in the end of 1980s. At that time, Shanghai, all the manufacturers, mostly from, for example, we have Shanghai Volkswagen, we have Shanghai General Motors, and also a lot of companies, Daikin, and some there come to, or Italian company come to China. So at that time, that the start point of Chinese refrigeration air conditioning industries. So during this process, so after 10 years, then Chinese companies start to develop. So only when Chinese companies started to develop, and then they started to have collaboration with the universities. So originally before, for our university, we had no chance because the Western, they are very strong in the research and development. So for the start point, they do not need. So now, if Chinese company, they come to European, so for example, for media, so they also come to there in collaboration with Italian universities. So at first, when my student come there, he asked Professor Wang, do you have some Italian professor friends? Then I introduced several friends for him. They visit, and then they start the collaborations, and they also need to absorbing students there. So this is actually, I think, the need. But at the moment, I think we still face a problem that Chinese university, now we have the global market, have more and more demand for the Chinese talents going abroad. And, but for example, the company so-called Qatar for the electrical battery, that's a so strong company, and alumni from our university. And so Professor Tiansuk, so she is the vice dean of the school, and in collaboration with Qatar. And so for the future energy, actually, we have an institution for this. So they really have a strong demand that they need the more talented people, Chinese, come to. They need to know the foreign market and also have a lot of foreign friends to work together. So at the moment, in this case, that how to make the universities that to build, to cultivate the student to meet the demand, not only in China, but also in the world. I think this is another thing that we are considering and try to make improvement. Thank you. Yeah, yeah.
Thank you very much. Well, are there any questions? Maybe it's time to say that it's over. Yeah? No questions? Thank you, everyone. Big thanks to all our noble guests. Big thanks to all who presented here and asked questions. Thanks very all. And I think that it's time to consider it's over. Our academic council, not council, academic colloquium is over, and we can stop here and switch to the last part, formal part with our guests. Thank you, everyone, for being here.
Thank you.